Welcome back. So in this video we're going to be exploring a little bit more about arithmetic and geometric sequences. More specifically, we're going to figure out what to do if you're missing some terms in the middle of a sequence. Now, the first sequence we're given is, I'm going to tell you, it's an arithmetic sequence, and we want to find the middle three terms. Okay, so we're missing three terms in the middle, and we want to find them given this is arithmetic. So in order to get from this 2 to this blank, we know if it's arithmetic, all we're going to do is add a common difference. So 2 plus that common difference would get us to the first blank. From this, we would have to add another common difference to get to the next one, and so on. We'd have to add another common difference to get to this one, then add another common difference to get to the negative 0.4. So now, we got to two known terms. We went from 2 to negative 0.4 by adding 1, 2, 3, 4 common differences. So we can set up an equation. So if we say 2 plus the 4 common differences, so 4 times d would account for the 4 common differences, is equal to the negative 0.4. Now notice we have an equation with only one unknown, so we can solve for it. So I'm going to go ahead and subtract 2 from both sides. I get 4d is equal to a negative 2.4, and now if I divide both sides by 4, I will get d is equal to a negative 0.6. Okay? Now, you should be able to tell that this is going to be negative. You shouldn't have to go through this whole thing. If we look at this, we're starting with 2 and we end up with a negative 0.4, so this is smaller. So if it's getting smaller, we know our common difference should be negative. So that's a thing to check out. And now what we need to do to find what is in those next terms is to get from the 2 to here, we'd add negative 0.6. Well, 2 plus negative 0.6, this is basically the recursive formula, isn't it? So we look at the previous term, which is the 2, add negative 0.6, which would be 1.4. We add another negative 0.6 to that 1.4 to get right here, and that would get 0.8. And then let's do it again. Add a negative 6 to 0.8, and 0.8 plus negative 0.6 is 0.2. And let's check. If we add that negative 0.6 one more time to 0.2, we should get arrive at this negative 0.4. So 0.2 minus 0.6, and sure enough, it does equal negative 0.4. So there was a way that we were able to figure that out. Okay, wasn't too difficult. And it was pretty simple to set up the formula. So again, we wanted to find out the common difference. How many times did I have to add a common difference to get from this term that I knew to this term? And I set up the equation. So it started at the first value plus however many differences I added is equal to the second value that I arrived at. Now sometimes you'll be given a value that's missing, or something that's only missing one term. So let's say we had an arithmetic sequence that you were missing one term in the middle, and let's say that went from 2 to 26. Okay? Now, there is what's called an arithmetic mean. This is just the average of two different numbers. Now, the mean is the average. Well, we know if we have to add some number to get here, and we have to add that same number to get here, the difference between this number 2 and this number is going to be the same as the difference between this number 26 and this number. So they're average. We need to just find the average of these two numbers. Remember, the average, you just add the two numbers together and divide by 2. Well, that's 28 divided by 2 is 14. And so there's my number in the middle. Now let's check. What do you have to add to 2 to get 14? So 2 plus 12 is 14, right? Well, if we add 12 from 14, will we get 26? 14 plus 12 does equal 26, so that works. So there's the way you can check it using the recursive formula again, just in the head, in your head. It didn't take much time, but that was the arithmetic mean, which to me is the very easiest way to be able to find a missing number in the middle of two others, given that it's an arithmetic sequence. Now, we can do a similar process with geometric sequences. Alright, so let's say we have a geometric sequence. Didn't want to do all that. The geometric sequence is 4 blankety blank blankety blank 108. So we have 2 blanks in the middle, and then 4 and 108. And we are told that this is a geometric sequence. So if we know that to get to the next term, we're just going to multiply by a common ratio. That would get us there. Well, again, we'd multiply by another common ratio to get to the second blank. And from there, we'd multiply by one more common ratio to get to the 108. So I need to set up another equation. So I have this 4 times 3 common ratios. So an r times r times r. Well, that's not 3r, but that is r to the power of 3. Because remember, when we multiply them, we add the exponents. Okay? So that's going to be equal to 108. And so now all I need to do is solve for r. So first I'm going to divide by 4. And I'm going to get r cubed is equal to 27. Now again, remember this, if you need to solve with this exponent, so r cubed, I have to take the cube root. And so now you got to ask yourself, these cancel out. What number times itself will give me 27? Well, that of course is 3. 3 times 3 is 9, times 3 again is 27. And so now let's look at this. So 4 times 3, go back up to the sequence. 4 times 3, the common ratio, that should give us 12. 12 times 3, 36. And does 36 times 3 equal 108? Yes, it does, so there's your check. Now, let's do something just a little bit different. So we got that answer, and that's all fine and dandy. Let's see if we can do something a little bit different. So let's say that we were given that this is not a positive 108, but a negative 108. How do you think that this would change our common ratio? So let's go through and change this 108 to be negative. And we know that a negative divided by a positive would just be a negative 27. And the cube root of a negative number, now a lot of times I get a lot of students say that that's imaginary, but let's think again. If we were multiplying it 3 times, a number by itself, 3 times to get to it, negative 3 times negative 3 is a positive 9, times negative 3 again, that would be negative 27, so all that would do is make that common ratio negative. And now when I go through, I multiply these by a negative 3. So 4 times negative 3, that's a negative 12. Negative 12 times negative 3, negative times negative, positive 36. And I'd get negative 108 if I multiplied by negative 3 again. Okay? Now, just like the arithmetic mean, we have another method, and we can use what's called the geometric mean. So if we're, and I like to use this if there's only one term missing. So let's say I start off with 2.5, and then I have a blank, and then go to 10. Let's see what this would happen. So if I have one term in the middle, I can find the geometric mean, or the average of those two, basically, the geometric average. And what I do is I take the two terms on the outside and multiply them together and take the square root of it. So my x in this case would be the 2.5, and the y in this case would be the 10. So I take the square root of 2.5 times 10, and so I get the square root of 25. And the square root of 25 is 5. Now, if we do this, we could technically be correct, because 2.5 times 2, so multiply by 2, gives me 5. 5 times 2, 10. So I do have a common ratio. But I am skipping out on something. What if my common ratio was negative 2? Would I still have arrived at a positive 10? So let's check that out. What's 2.5 times negative 2? Well, that's negative 5. Negative 5 times negative 2, well, hey, that's a positive 10. So, I see that I have two possible different answers here. So I have a positive or negative, so plus or minus 5. Now, the reason why is I'm only given the two separate terms, and if I were to do that the previous method, I would have multiplied by two common ratios. Let's try to show that here. So it'd be 2.5 times r squared is equal to 10. Or divide both sides by 2.5, I'd get r squared is equal to 4, and square root. Remember, when we square root an r squared, I have plus or minus two different answers. So I could do a positive 2, because r squared could be positive 2, because 2 squared is 4, but also negative 2 squared is also 4. And so that's the one thing you need to watch out for geometric series. Thank you. Bye.